folks, I'm Dave.
And I'm Ben.
And we will get tired of saying it eventually.
Eventually, like 20 videos down, and just be like, alright.
Yeah, okay, let's just, come on.
Let's get over with.
There are a few YouTubers actually that I follow in a few different areas who have some funny intros. They sing songs at the start of every video.
Let's start doing that.
We could, but maybe when my voice is a bit better. But we'll see. But for now, I like the intro as it is. Okay, so standard stuff to get started. Please like, share, comment, subscribe. It's truly, truly, truly appreciated. Get yourself down to FUZEarena.com if you haven't already. Check it out and watch all of our videos. Even if you are a complete expert, go back, do Hello World again. Why not? Why not? Feel good about yourself. You know,
do it with your eyes closed.
There you go. Add a challenge to it. Add a challenge. Actually, Ben and I, we were talking about a challenge video, weren't we? Where we were saying if we re-record every single project, it's a 24-hour video, and the challenge would be that you have to complete every single line of code as it's being done without pausing the video once, or even leaving the desk, or wherever you happen to be sat,
or even taking your eyes off of the screen.
You can't even blink. Or breathe. No, do breathe. Okay.
And blink.
It's really hard not to blink, actually. So yeah, your body will start screaming eventually. We'll just do this. That looks good. That looks good.
Yeah, that looks fine.
Okay, well, that's a good intro. I like that. Let's get started. So, in the last video, we covered a requested topic, which is sprites. How to use the FUZE sprite system to set up some simple sprite images and manipulate them. And that's exactly what we did. We ended up with a slime that was moving around and a weird little sort of guy with one eye rolling down an imaginary hill, turning red and getting faster. It was good. I liked it.
I liked it too.
But we've left it for a separate video to cover the more advanced side of using the sprite system. Now, when you are using a single image, just like we were in the last video, it's a lot easier because you're always just using that one image. And there's no animations, there's no nothing. You can make it look like it's kind of animated, like we were doing at the end there with the scale adjustments. But if you go into the FUZE media, there are some really awesome sprite sheets. Tile sheets, sprite sheets. There's a lot in a bunch of different artists, but for these videos we're going to be focusing on Untitled games, because of reasons. There's no bias here. I find his art really universal. You know? It's kind of for everybody. It's a really nice, welcoming style. Some of the other artists have a really definite style that I really love, but for the purposes of this video, I think some nice, simple sprites would be perfect. Now, there is one particular one which I've been looking at. It's this one, the Knight. So if I just open this, this is what it looks like. Now, if you've never seen anything like this before, fear not. Whenever you've played a 2D game, this is your character. If you're looking at animations, a thing walking or attacking, there's a file like this that exists, and the game is animating through these separate frames. And we can actually preview each of these frames. And if I just zoom right in, you can see that each one has a number. We've got 0, 1, 2, 3, 4, 5, 6, 7, so on and so forth. And if we can select a region, so if I choose, if I press the A button on 0, for example, you'll see that straight away the text at the top changes, and it says you can press the plus button to view this as an animation. Now, right now we only have one frame selected, so it isn't a very good animation. But if we put the end of our animation range to the 3rd frame, we can now, as you can see, it's updated. It says start tile 0, end tile 3. We can now view that chain as an animation. And there he is. So he's running along there. And that's just a combined list of all of those images. And I like to make this comparison to flipbooks. You know the ones, Ben?
Yeah.
Pretty much everyone's used one of these. It is a classic. You can make them really, really easily if you just draw lots of different pictures. That
if you're very good at drawing.
Or stick men if you're not. You can always just go with stick people.
Yeah, true.
Know, doing a little wave or something.
And if you're patient enough.
It does take some patience, it really does.
Which I most certainly was not.
I did 3 pages, that was it. You know, I'm a simple person. That's what's happening. You're just seeing the images so quickly that your brain says, oh, that's moving. but actually they're all separate images. Now we can actually paste this animation data into FUZE. We'll get around to that in a second because there's a particular function that we want to use with that. So let's just go out of here and back again and into our program. So we're animating sprites. You might recognise this sort of setup from the previous video. Let's just cover it again just in case. We're loading a sprite sheet this time, so we've named it appropriately a sprite sheet. There's our file. Our sprite variable, the handle which stores the sprite, is now called night because it's a night. There you go. We thought we'd just be a bit more sort of, not professional, but it's a bit more practical this way. Set sprite image. We need to set our sprite sheet as the image for our sprite, and then we're just making sure that it's in the middle of the screen and it's got a nice big scale as well. And then our main loop, draw sprites, clear and update. This one, update sprites, we need that if we want to see things changing on the screen with our sprites, but it won't be necessary yet. We could actually comment this out for now, and we'll see the effect. Now, if I run this program, we will get this. It's quite confusing. And it's because that's our image. And FUZE thinks, okay, well, you wanted this whole image as your sprite. Because really, a tile sheet is just an image, but it's separated into a grid. And we've told it what those grid numbers are. And, you know, they're the tile indexes, if you like. These are the different tiles. But you're looking at the entire thing here. So if we want to just see one of these...
This is the entire flipbook.
Yeah, exactly. Every single page of the flipbook laid out.
Yeah.
Laid out. If you didn't realise from the last video, my voice is a little bit dodgy for the last 2 days. Please bear with me. I do apologise. But we thought, you know what, better to just bring the videos to you rather than wait. Could be weeks until this clears up. So you're stuck with me for now like this. So yeah, if we had all of our pages in our flipbook stuck on the screen, this is exactly what we're seeing. But we want to combine certain pages of that flipbook into a little mini flipbook and play it. Man, that's a good analogy. It's a really nice analogy.
It is. I'm quite impressed with that.
Yeah.
I like it a lot.
Okay, if we go back into our code, what we need is a function called set sprite animation. Ben, could you type that in for me? Now, set sprite animation needs 3 arguments, or is it 4? It's 4. It's the sprite first. In this case, we've called him night. And then we have the beginning tile, the first frame, then the next frame, then the last frame, and then the speed, the frames per second that we want this to animate at. Now, if you can't remember what you had in your sprite animation data, there's a really clever thing you can do. And that is if you go to media, and you'll see that media is also glowing here, because set sprite animation is another thing that you can paste information into. Okay, we've had some audio difficulties here, so I'm just going to re-record this bit of audio and explain what's actually happening on screen. So I do apologise for the hiccup, but what we're doing here is we are pasting animation data from the FUZE asset viewer into our code. Now, when you've selected a range of animation as we have here, you can preview the animation using the plus button, and you will see your animation taking place on screen. Whilst it's here, you can adjust the FPS using the directional buttons in increments of 5. Now, you don't have to stick with these FPS values. You can make them whatever you want in your code, but it gives you a good idea of the sort of feel of animation that you're going for. When you've got the FPS that you want, you can press the X button on the Joy-Con to paste that animation data into your code. Now, it's assuming that you're already in the set sprite animation brackets because it adds the commas between the bits of data that you'll need. Now, you can, of course, just change all of this on the fly when you want to. Now, if we run this, you'll see that without having update sprites in the loop, you'll see no movement. In fact, it has set the animation data, but you're only seeing the first frame. If you want to see the movement happen, you will need update sprites in your loop. Scale of 10, because that is not so big. There we go. Nice and big moving night. I really love this stuff. It's so simple. This is the thing that amazes me about pixel art and pixel artists. Just something I can't do. And the patience and just there's only
The detail. Yeah.
in the lack of detail. It's the lack of detail that makes the detail
Well, yeah, the detail using
such
big
minimal
blocks.
things.
Yeah.
It's so awesome, so awesome. Right, let's go back. Now, it should just be nice and easy then to have our knight move in different directions and animate in the way that we want. Now, if you want your sprite to just have a set animation, so for example, let's say that you're doing a side-scrolling game and you've got some characters that just stay perfectly still, NPCs, and you might want them to just be in an idle animation, like a going up and down slightly, the standard, the over-exaggerated, I'm just idle. I'm totally relaxed. That's how I always stand. I move my arms like this, like a real chicken.
And then forward and back as well.
This is what we do all the time when we're just doing nothing. Actually, it's quite a lot of effort to do that. It's not idle at all. Yeah, if you had a situation like that and you had an NPC and they didn't need to move, they don't need to do anything, then you could just set the sprite animation outside of the loop and leave it. You don't have to bother with it again. But if you want to change the set sprite animation, we will run into a very interesting problem. And maybe you'll understand this problem straight away, maybe you won't. I'm hoping that you don't, because it's a chance to learn something really, really good, and this will help you understand program flow in a much better way. It's something I actually really struggled with at first, and then eventually it clicked. So hopefully I can get it to click for you as well, and Ben can help me. So Ben, I want to, when I'm pressing up, I want to change the animation so that my knight is facing up and that he's walking upwards. So if we're just thinking simply here, it should just be a case of if c dot up, right? If c is our controls. Actually, let's call the controls. C equals controls 0. So that's why I use the c variable. Now, of course, if you haven't seen our controls video, I do recommend that you go and watch it, because that will give a whole world of meaning to this whole c dot up, c dot down thing that I'm talking about. But it's actually quite self-evident as well, so maybe you don't need to. Okay, so if we do, actually, first of all, let's just look at our knight again, because the up animation data is on 12 to 15. So let's just remember that, 12 to 15. So it should just be a case of an if statement, right? If c dot up, then set sprite animation. We'll need to do it to the knight, and it was 12 to 15. And we'll keep the frames per second the same, just for consistency. And then end if. Now, if you're like me, and hopefully you are, this would make perfect sense. And you might think, well, yeah, that should just work. But we're missing some really key bits of information. So let's run this and see what we get. So he's facing down. Now, if I'm pressing up, I'll just put my Joy-Con here so it's visible. I'm going to press and hold the up arrow. Okay, I've got a problem. It's just stopped. Now, if I let go, it starts animating. And that's weird, right? If I press up, that's when he's not moving. When I'm letting go, that's when this is not what we want. We want him to move continuously as I'm pressing the up arrow, but then to stop when I let go. And to understand how to do this in a way which will help you apply this to every single program that you will ever write, we need to understand a bit of a weird concept. Now, this concept has a special name, and if you are like Ben, and you've made a good decision and you've decided to take computer science at college, then you might know this as something called a rising or falling edge. Rising and falling edges. But if you're like me, that term will just confuse you. And I think that it's really good that we have both sides of this, because you're coming from a place of sort of more traditional academic, and I'm coming from just like coding. I just learned with FUZE. So for me, it helps to imagine it in a bit of a different way. Now, what we're essentially doing is, rather than just checking if c.up, because if we think about the way this program works, okay, let's bear in mind that it's a loop. So this is just happening again and again and again, and it's happening very, very, very quickly, 60 times every second. So let's imagine that we are reading it as we go. We clear the screen. We call the controls. Now let's say that we're not pressing the up button. If c.up then, does this if statement trigger?
No,
No.
it's false.
It's false.
We skip past it.
C.up is false, we skip past it. So we ignore it. We do not set the sprite animation. We update our sprites, which means that we are in the current animation that we've set before the loop. And then we draw everything, we update the screen, and we repeat. So that's one frame. That's only one frame. Let's go to the next iteration of the loop. C equals controls. Let's say that on this frame, I press the up arrow. Sorry, the up directional button. And this time, c.up is true. So c.up is true. Now it's true, we are triggering set sprite animation, and that will reset the sprite animation to have a start frame of 12, an end frame of 15, and to have 10 FPS, but that hasn't changed. Now we update sprites, we draw sprites, update and repeat the loop. Now, unless you have the fastest fingers in the Wild West, in fact, not even the Wild West, but the universe, you might find it quite tricky to press a button for one frame. Doing something on one frame is unbelievably precise. And even if that was the case, we'd need to keep pressing it again and again. It's not really tenable. It's not really a realistic situation. So the chances are, if you were pressing up, then you're holding it down for more than one frame. So bear in mind, c.up is still true on the next way around the loop. And so we set sprite animation again, and we start the frame count again at 12, with an end frame of 15, and then we update sprites and draw sprites, and the chances are you're still holding it down, because frames pass 60 times a second. So, 1. Oh, that was 60 iterations of a loop. So, for 60 more of these...
Or in other words, it just keeps resetting it back to the same point.
Thank you, Ben.
As long as you're holding down.
You've shortened my explanation somewhat there. I was going to get there, I promise. But exactly. As we're holding it down, we're saying frame 12, frame 12, frame 12. If we want the sprite animation to change and to keep running, we only want this to happen once. Just once. So, to do this, we will need something a bit more tricky, and it looks really, really cool when you get it working. And this is the part that is the rising and falling edge, or what I call it is just storing the old state of something. So we need to know what the controls are at the start of the loop, but then at the end of the loop we want to know what the state was. So when we restart, we know what the controls were doing on the last frame. And all you need to do with this is just make another variable. But we should make controls global here. This will get around some problems later. So we've got C. Let's do old C. And just for my peace of mind, can we not do the camel case on this one command? It's funny, right? Because this is so strange, because on all the normal commands that I would camel case, you haven't camel cased them. And the one variable that I wouldn't camel case, you've camel cased it. So, or underscore. That's also a nice one. So old C, we've made this variable. Just call it C for now. And then make it equal to C. So we've just stored whatever the controls are doing. So C and old C, when we start the loop, are exactly the same. They're just doing nothing. We read the state of the controls. And now, at the end of our loop, after everything's said and done, and you can do it here actually, that's just as good. We'll do old C equals C. So let's just think about that. Read the state of the controls, go through the game loop, figure everything out, and then at the end of the loop, store what the controls were doing in a variable called old C. And then when we reiterate the loop, the new information might be different to the old information. What we need to do here is to add something to this if statement, and then Ben and I will do some kind of silly demonstration and hopefully it will work. So we need to check if you're pressing up, but you weren't already pressing up. So that will look like this. It's if c.up and not, oh, exclamation mark.
Yeah.
Old C dot up.
Not dot up.
No, that's, not old C dot up. So if you put a dot up at the end of that.
No, sorry.
Yeah, that's all right.
Confused?
No worries. So Ben, you actually program in a few different languages as well, don't you?
Yeah.
So that all the conventions, they tend to differ.
Yeah, like I just wrote not.
Immediately wrote the word not, which maybe we should have, I think there was some talk about it at some point. Now, this is one of those cool looking if statements. It's like, oh wow, what's going on here? But I just want to, can I just borrow the keyboard a second? Just to reiterate how, this is just a simplified version. This is what we're actually saying. Oops. Oh, terrible. Exclamation mark equals false. So if you are currently pressing up, but you weren't pressing up before, it's just that I personally forget about double equals all the time. So I tend to just ignore those and use exclamation mark for not. And you don't actually even need to check if something's true, you just do if this. It's the same thing. Right. So now you need to be pressing it, but need to have not been pressing it on the previous frame. If we give this a try, and I'll do the same thing again, I will hold down the up. I'm holding it down, and he's still behaving. If I let go, he's still walking. Now we haven't got anything to make him stop, so we're not expecting that yet. But we don't have this problem anymore. We don't have this really weird behavior where it's triggering set sprite animation on every single frame. If you can get your heads around this, that is a really, really important thing to realise. And it took me a while. It took me longer than I want to admit. But I should be the benchmark for the layman here. So, just to be really silly about this, imagine that...
Us? Silly?
Us? No. Us, the paragon of sensibility, paragon of seriousness. Actually, I'm the paragon of truth. Have you got a paragon title, Ben?
I don't believe so.
Paragon titles are universal amongst most of the FUZE staff. It was originally just the original team. Paragon of judgment, paragon of truth, and paragon of wisdom. We'll get you one, Ben. We'll get you one. Paragon of helping Dave out. No.
Sounds about right.
No. Paragon of hilarity actually is quite a good one. I like that one. Okay, that's way off topic. So yeah, as we were saying, Joy-Con staff. Let's imagine that Ben is the new.
I'm the new.
And I am the old. For obvious reasons. Okay, so Ben, at the start of our program, you get given a value. Let's say that you are true. You're true, right? You're a 1. You're not a 0.
So that's true, that's false.
Yeah. True,
Let's go with
false. True, false. Okay, cool. So Ben's true. Now, all the program happens. By the time it gets to me, I'm the old variable, and I need to now store whatever Ben's doing in the old variable. So Ben's true. Okay, I guess we're true then. Okay, this might be the case for a few frames. Now, on one of the frames, Ben's value is going to go false. And at this point, we're different. So, at this point, Ben is false. I'm true. Can we get through this if statement? Ben needs to be true and I need to be false to get through this if statement, so that doesn't really work here. Okay, fair enough. So we're going to go through the program. I store the old version of the variable. It's false. Okay, I'm now false. And then we start a new frame. Now let's say at the start of this frame, someone presses the button and it becomes true. Now Ben is true and I am false. C.up is true, old C.up is false, and we trigger the if statement. But when we get to the end of the variable, the end of the loop, I'm storing the old state, I'm true again, and we're back to square one where we can't go into the if statement. Try and get this into your head, because it doesn't just work with controls, it works with anything. And you'll see it all over the place in more practical and professional programs. It actually allows you to do some really cool stuff. And one of the applications that you might have seen it with is with something called a state. If you've got a state, then you can check if the new state is different than the old state. And if it is, let's change what we're doing. Okay, with all that said and done, we're going to jump out of this program. Pardon me, and we'll go into one of the ones I made earlier, and we'll do a classic move here. I believe it's Animating Sprite. Is it this one? Yes.
Yes.
Now, there's a fair bit here. Yeah, I think so. We can test it because it should just move. Not at all here. When I press up and hold it, he should move up and move.
Yep.
When I let go, he stops. If I hold down the down arrow, he moves down and moves. When I let go, he stops and he remains in the idle. And it's actually a really nice little animation. Now, we've only got up and down movement here, but what we will explain can be just applied to left and right and any sprite sheet. So, let's go through it. Same thing again. All of the start is exactly the same. Now, to begin with, I've set the sprite animation as 0, 0, 0. We're not moving anything at a frame rate of 0. And now what I've got are a load of these variables. And these variables are to make it easy to keep track of a load of data. Because if we want to have a set sprite animation for moving up, and that's one set of frames, or for moving down, that's another set of frames, or for moving left, a whole other set of frames, in every single direction, every single state you might want, you'll need another set sprite animation, and you only want it to happen once. This ends up getting quite cluttered in your program, and it can very, very easily lead to a messy program, which is fine if you're totally okay with that. But with me, I found it really helped to start it in this way, and I wanted you to understand the problem before we went into how to set this sort of thing up. And you will see this all over the place. It is in the FUZE game tutorial in the help, which is the little platformer using the Kenny assets, which is really funny. But what we have are variables for the number of our animation data. In fact, maybe I should have put the animation data first. Let's have a look at that first. In fact, tell you what, I'll do that. We'll go take this and put it down here. Okay. So here is the start and end frame value of each of the movements. And I've structured it in the same way that the sprite sheet is structured. So if you look at the sprite sheet, go down to the right, you'll see that it's laid out in a particular way. Now you don't have to lay it out this way, I just did it for my own sanity really. We've got, across the top, we've got the down state. Across the next line we've got the left. Then we've got right. Then we've got up, and then we've got the idle states for each direction in the same layout. Down, left, right, up. So I went with this layout for the array. So our first, and it's actually an array of structures. If you remember from the last videos, we've got an array here. Inside that are a bunch of structures, and they have a dot start property, which is the first frame, and a dot end property, which is the last frame. So the start frame of the downward animation cycle is 0. The end frame of the downward animation cycle is 3. And it's like this for all of them, apart from these ones that have the same start and end, and that's just the idle animation for down, left, right, up. So I don't want it to animate between frames, I just want it to stay on the same one. Now, rather than having to remember the numbers for all of these, 0 is down, left is 1, right is... that gets quite annoying.
Just do it all at the start with variables.
Just make variables. That's exactly what we've done here. Down, left, right and up. Idle down, idle left, idle right, idle up. And these will index into this array so we know which data we're using. I do apologise if I haven't quite got the code in the right place there, because I always forget that we take up some of the screen here. But it's not much, actually. It's not much.
We need to get like a thing on our monitor.
Good idea. Yeah, so we can know, or just get a little post-it note, stick it there, and do the budget version.
Yeah.
Okay. What we've then done here is created a property to store the state that the direction of the character is in. So to begin with, he's going to start in the idle down state. He's just facing towards you. And then we've made a property called old state, which in the exact same way as C and old C, just stores the current state that he's in. I've also got a variable here called move speed, which I can use as the Y speed, the X speed, and I can make it negative, positive, and we can keep the same speed throughout. We've then got our C and old C variables, just as normal, And actually I've also included a cheeky set sprite camera. Now I could have just done scale here and used G width divided by 2, G height divided by 2 to put it in the middle of the screen, but the sprite camera allows you to actually almost forget about the screen dimensions, and it turns FUZE into more of a camera system. So what this means is, put 0, 0 of the screen, which is the top left, as my sprite camera, and I want to zoom in of 8, so we're just zooming in by 8. Now that 0, 0 part here is going to be the centre of my sprite camera, and what we do here in the loop is we do centre sprite camera around those coordinates. So we essentially just move the whole screen so that the top left is now in the middle. It is optional, but I wanted you to just see these commands so that you have some introduction to them, because when you're using sprites, Sprite Camera, it makes things really, really easy. If you want a good example of these, check out the FUZE Super Platformer program, where the guy who actually made the Sprite engine uses them to awesome effect to make a side-scrolling platformer, featuring our little knight character, funnily enough.
Oh, really?
Yeah. In fact, it's really cool because if he gets damaged, his armour comes off and he turns into the monk,
yeah.
who isn't wearing any armour. So it's like his armour flies off. It's really silly. Okay, we update our sprites, we read our controls, and here is the if statement. What I will just do, actually, is get rid of this one, because it's this here that is really important. So I won't get rid of the clipboard for now, because I would like to put that back in. Let's just read this if statement. If you're holding down, because I want him to move the whole time that you're pressing down, and what I do is we say change the state to down, so we know that we're using our animation data from the down animation cycle. We also increase his Y position, so we're moving him down the screen, by the move speed. We just take the Y property of the knight and add the move speed property. That's all we do in that if statement. There's nothing fancy going on here with the rising and falling edges. But the next one is a rising and falling edge. What we're doing is we're checking if you are not pressing down and you were previously pressing down. So when you let go, basically. You can think of these as when you press it and when you let go. If you are not pressing it, but you were before on the previous frame, then we change the state to the idle down position, which just means he stays still and is facing you. What we have then is another really important rising and falling edge if statement, or old and new state checking if statement. This one's a bit fancier though. We're saying if the current state of the knight is not equal to the old state, then set the sprite animation. And this line might need some. Have you seen this? Look. Now, don't worry, if this suddenly starts to scare you, stay calm.
Fair enough.
Fair enough. For a start, fair enough. Definitely then. But once you know this, you can feel very, very cool just writing your amazingly complex properties. We're setting a sprite animation of our knight. And the starting frame is the start property of the knight animation data array, and we're indexing that with the state of the knight. So if it's down, down is 0.
Dave, if you scroll up
and have a look at it,
yeah,
probably a good idea. So let's say that the state is down, which is 0. And there's our knight data array. The first element of that array has a start of 0 and an end of 3. So remember those values. Let's go back down to our if statement. And I think my cursor is still here, yep. So really, when the knight has a state of being down, this entire mess of stuff here is just a 0. That's all it is. And this whole mess here is just a 3. But the reason it is so complicated looking is, for one, I've called my arrays and structures quite long names. So when I'm actually coding by myself, just for me, I tend not to call it .start. I call it .s.
Yeah.
And .e for end. And I wouldn't call it night data. I'd just call it like KA data for night animation data. And that actually reduces everything down by quite a lot. But of course, for the purposes of teaching, it's not very helpful. And this really helps us just sort of read and remember what's going on. So really that just says 0 and 3. Now remember, we only want to trigger it once. So if the night state is still down on the next ride, on the next time, I was going to say next ride around the loop, on the next time around the loop. I mean, I always make the comparison to roller coasters in schools, so that kind of maps on to the sandwich, but you don't eat a sandwich from the top piece of... Imagine that. Here's my sandwich. I just put my face into the bread, and then I somehow go back to the start again. Just realised how strange I looked at just doing this. I'll try and eat a sandwich that way next time.
That could make an interesting game.
It would have to be a really small sandwich, you know.
That could be like your oh god, I can't remember the name now. The one that we changed to make the toast.
Oh, 3D Crazy
3D
Shooter.
Crazy yeah. When you reach say 1,000 points,
Yeah.
you have an animation of just someone eating a sandwich.
You could
from
do.
the top to the bottom.
I mean, yeah, maybe it could pause the game
Yeah.
and break out
Yeah.
completely, and then it could just be Colin the robot.
Yeah.
And then like you have a sandwich in from the FUZE assets, and then he just sort of goes and just consumes it from the top down.
And then on to the next level.
On to the next level. That's your cutscene.
Yeah, that's brilliant. Someone make it.
Well, actually, in 3D Crazy Shooter, I came up with a story idea for it, which
Okay.
was that Colin is actually the cleanup robot who's cleaning up the assets that you've left behind.
Okay.
So all the assets are flying at you because they're all like waste that needs to get cleaned up. So he's going around cleaning it all up. And that's thirsty and difficult work and hungry work. So he's got to have a sandwich and a break. I've just justified it, mate. Right, I'm going to do that. And I'm going to write a whole story and we'll do it. And if someone else wants to try, please go ahead. So where was I? Right, so let's remind ourselves. This is the really, really important bit as well at the end of the program. We store the old state, I beg your pardon, we store the current state into the old state and we store the current controls into the old controls. And now we can just trigger things once, trigger things twice. We have total control doing this. And it's really, really helpful. If the state changes, you know, you could also go even fancier. And if you wanted to have, like, for example, if you had movement animations, but you also had attacking animations, you might want some code to apply to when they're in a jumping state, for example. So you might want it to jump in the air, move around. But you might also want to attack. So you might want to have two different states. You could have a direction and a state. So my direction is up, but my state is this. Or my jump state is true, or I'm jumping, something like that, and I'm also attacking. You can get quite complex with all this stuff, and it also goes even more advanced when you get into binary states, which is something really, really cool that I'm sort of just getting my head around. So when I do, we'll make a video about it, and you'll have to wait till then. But in the meantime, I'll be working hard. Okay. As you saw before, and I got rid of this if statement, I'll paste it back in. I just simply copied and pasted this one, replaced everything with up, all the downs with up, and we've got our animation. All we would need to do to make it move left and right is just do the same thing but with left and right. Let's just do that, and then we can I think call the video a day there, because I think we're maybe getting on a little bit. So we've got this one, and my Joy-Con has run out of. It wasn't moving when I was down here. It lost connection. Okay, and we've got this one. So I think, Ben, if you just type in left for me, and then I can do some fancy copy and pasting. That's all good. That's all good. We want idle left, and that needs to be a capital L. And on this one we want right. We take that, we change the state there to right. That's all fine, that's all fine. We change the state to idle right. And, or, idlate. Idle right.
Oh, do you not need to change the controls?
I do indeed. Yeah. I do need to change the controls. Why did I forget that? C dot up, C dot right, and let's get our left back. In fact, yeah, Ben, you can just do this one for me. And here as well, if you please. Let's see if it works. Oh, I know why I know why that's happened. I was too fast. I was too eager. Classic mistake. Look at what we're doing.
You need to do the other things as well.
All the other things I forgot to do as well. We're still changing the Y position by the move speed. So if they're going left, we want that to be negative. So it should just be an X here. And I believe it should just be an X here. And this should be a plus. That should do us. So we've added these two if statements. And let's see. Fantastic, eh? Look at his little...
Oh, yeah. I forgot that you'd put in the left and the right
animation data.
Yeah.
Exactly.
Yeah.
This is the beauty of it. And, you know, when you've got this going on, it's very, very easy to set up again. Now, please do not feel bad if this has made your brain hurt a little bit. If it hasn't, awesome. And the last thing I want to sound is condescending or patronising. So some people find this very, very easy to understand. And some people have had a lot of practice. Some people, like me, find it very, very difficult to understand, also to not hit the escape key. Some people, like me, find it very difficult to get to grips with at first, and I need a lot of practice. So please watch this video as many times as you need, pause it, and I really urge you to write the program with us. And instead of using the knight, try a different sprite. Bit of a rhyme in there. Not too bad. Could be better, but off the cuff. Okay, I think that about covers it for the more advanced things that we wanted to cover in the sprites. I hope that this has been illuminating and that this allows you to make your own sprites, bounce them around the screen, adjust the scale, and make all kinds of other things happen. Feel free to combine what we had going on in these two videos as well, because with the different states you could make it pulsate in the scale, you could make it turn different colours. If the state changes, do something to the colours. The world is your oyster with this sort of stuff. The world is your digital oyster. Right, Ben, any closing comments? Anything I've forgotten here?
Don't believe so, other than...
What have we done? Man after my heart there. I really like that sort of nice, laid out. In fact, if I was going to be really, really annoying, we could go... You know what I'm going to do, don't you? What I was thinking.
Possibly.
I was thinking of getting the, if we did this sort of thing, so all the tens and the units line up beautifully. And we'd have to do it over there as well, then we can miss out on that space. Oh, look at that. Beautiful presentation. Totally optional, of course, but we like it.
We do indeed.
Okay, guys, I think that's long enough.
Yeah.
I've been Dave.
And I've been Ben.
Thanks so much for watching. Leave comments, like, share, subscribe.
Subscribe.
I've said it every single time now.
Subscribe a comment.
If you could inscribe a comment into the box using a keyboard and then leave it on the video and then subscribe and hit the notification bell if you want to get a notification whenever we release a video. We are planning a lot more, so there won't be a big delay, and I look forward to the next one. Cheers, guys.